Okay, 5.12 is behavior of implicit relations. So all this notes is telling us, and to start off, it's not related to 510 or 511, right? It's completely different. It's just saying that we can still use the first derivative test and the second derivative test when talking about implicit derivatives. So it says implicit relationships still follow the same rules as functions. If dy dx is equal to 0 or dy dx does not exist at a certain point, then that point is a critical point. So pretty much restating the first derivative tests. If d squared y over dx squared is greater than 0 at a point, then we can say that it is concave up at that point. Okay, same is true as if it's less than 0, we would say it's concave down at that point. Okay, so on the first example, it says consider the curve 3x cubed plus 3 equals natural log of 4y squared in the xy plane. At the point negative 1, 1/2, is the curve increasing or decreasing? So in order to find increasing or decreasing, which derivative are we taking? Yes, it's the first derivative. First derivative. Yes, the second derivative is for concavity. So what that means is we need to take the first derivative, and since this is in x and y, remember every time we take the derivative of y, we have to write what? dy dx. So we have 9x squared is equal to 1 over 4y squared times 8y dy dx. So I just took the derivative. The derivative of 3x cubed is 9x squared. The derivative of 3 is 0. It goes away. The derivative of the natural log is always 1 over whatever's in the parentheses. So that's why I have 1 over 4y squared. And then we have to use the chain rule and take the derivative of 4y squared, which is 8y. Okay. Now we have to get dy dx by itself, but before we do that, can we simplify anything here? The 8 and the 4. Okay, so the 4 is gone, the 8 turns to a 2. Anything else? The y, so this y is gone, and there's only one y left here. So that means we have 9x squared is equal to 2 over y dy dx, which means dy dx is equal to what?
9x squared divided by 2y?
Not quite. Yes, 9x squared y divided by 2, because in order to get rid of 2 over y, we have to multiply by the reciprocal, y over 2. Okay. So once we find dy dx, we are then going to solve dy dx at the point negative 1, 1/2, which means for all the x's, we're plugging in negative 1, all the y's, we're plugging in 1/2. So this is 9 times negative 1 squared times 1/2 over 2. And the goal here is to see if this is positive or negative. We don't really care about the number itself, just if it's going to be positive or negative. So since the negative 1 squared is going to turn it to a positive 1, technically we have a positive number being multiplied throughout the numerator and a positive number on the denominator, which means our answer is going to be positive. So this simplifies to 9 over 4 if you want to simplify it all away. And we know that this is greater than 0, which is positive. So since the derivative is greater than 0, is the curve increasing or decreasing? Increasing. So we would say the curve is increasing at point negative 1, 1/2, since dy dx, or the first derivative, is greater than 0. And that's our answer. Okay, any questions on 1? Okay, number 2 says consider the curve x squared minus 3 is equal to e to the y in the xy plane. At the point negative 2 comma 0, is the curve concave up or concave down? Because it talks about concavity, we're taking what derivative? The second. Okay. So in order to take the second derivative, we need to first do the first derivative. And so the first derivative of this would be 2x is equal to e to the y dy dx. Derivative of x squared is 2x. Derivative of that negative 3 goes to 0. And derivative of e is always the same. So we have ey dy dx. Then solving for dy dx, we get 2x over e to the y. Then we have to take the second derivative. And in order to do the second derivative, what rule are we going to do? The quotient rule. So we have d squared y over dx squared is equal to, remember the quotient rule states that we take the derivative of the top, so this is 2, times the bottom, e to the y, minus the function on the top, 2x, times the derivative of the bottom, e to the y, dy dx, all over what? ey squared. Okay, now that we have the second derivative, in order to complete this, we need to plug in the first derivative. So really, we have 2ey minus 2x e to the y times 2x over e to the y, because that was the first derivative that we just plugged in, all over e to the y squared. Can we simplify anything here? Okay. We could factor out, well, not necessarily.
Oh, no, because it canceled.
Yes, because look, this e to the y and e to the y cancel, which means we have, and I'm going to continue up at the top, 2e to the y minus 4x squared over e to the y squared. So that is the second derivative. Now that we have the second derivative, we're going to plug in the point, negative 2 comma 0. So that's d squared y over dx squared, solved at negative 2 comma 0. That means we're plugging in negative 2 for x and 0 for y. So we have 2 times e to the 0 minus 4 times negative 2 squared, all over e to the 0 squared. This gives us 2 times 1, because e to the 0 is 1, times negative 4, or sorry, minus 4 times a positive 4. So let me just write it out. 2 times 1 minus 4 times 4 over 1. This gives us 2 minus 16 over 1, which is negative 14. Is that positive or negative? Negative. Since it's negative, are we going to have concave up or concave down? Concave down. So we would say the curve is concave down at the point negative 2 comma 0, since the second derivative is less than 0. Solve at. Okay, any questions on 2? Nice brain break from yesterday. Right. Right? You know you're learning a lot, right, when this is the easy stuff. Okay, number 3 says consider the curve y cubed minus y is equal to x squared in the xy plane. It is known that dy dx is equal to such, and d squared y divided by dx squared is equal to such. At the point 0, 1 on the curve, is the point a relative max, relative min, or neither? And we have to justify our answer. So in order to solve this, we have to first check if that point is a critical point. So we need to check that 0, 1 is a critical point. And how would we check that? The first derivative. The first derivative should be equal to 0 or undefined. Does not exist, right? Once we confirm it's a critical point, then we check concavity. And we do that by the second derivative. Okay, so let's do the first step, and that is to check if it's a critical point. They already gave us our derivative, so dy dx is equal to 2x over 3y squared minus 1. We are going to solve dy dx at the point 0, 1, and we get 2 times 0 over 3 times 1 squared minus 1. That gives us 0 over 2, which is 0. That is what we were trying to do. We were trying to see if our derivative was equal to 0, which proves that 0, 1 is a critical point. So we'd say yes, 0, 1 is a critical point. Okay, now we're going to take the second derivative, which again they give it to us, and we're going to solve it at the same point, 0, 1. And we're trying to see if that point is going to give us a positive or negative value. So I have d squared y over dx squared is equal to 2 over 3y squared minus 1 minus 24x squared y over 3y squared minus 1 squared. I'm going to solve d squared y over dx squared at the point 0, 1, which means I get 2 over 3 times 1 squared minus 1 minus 24 times 0 squared times 1 all over 3 times 1 squared minus 1 squared, which gives us 2 over 2 minus 0 over 2, which is equal to what? What number is it equal to? Not 2. 1. Right? 2 divided by 2 is 1. 1 minus 0 is 1. 1 is positive, so it's greater than 0. So this tells us that at that point, we are going to have what? Concave up. So we're going to say at 0, 1, the curve is concave up. Okay. But is that the question it's asking us? No. So we have to take the information that yes, it's a critical point, and yes, the curve is concave up at that point to determine if we have a relative max or relative min. So knowing that, what would it be? A minimum, right? Because if we're concave up, good, we have that positive parabola shape, which means we're going to have a minimum at the bottom. So we would say the point 0, 1 is a relative minimum since dy dx is equal to 0. That's the first part where we proved it's a critical point. And d squared y over dx squared is greater than 0, which tells us that it's concave up.